Welcome student. Today's topic we are going to discuss about meter bridge or slide wire. It is already we must have seen Wheatstone bridge. It is this instrument is the simplest practical application of Wheatstone bridge to measure an unknown resistance. That is, when bridge is under balanced condition, we use this formula, that is P by Q is equal to R by S. That is, this divided by this is equal to this divided by this. We can say like this: P divided by Q is equal to R divided by S. This is the basics of meter bridges, nothing but Wheatstone bridge. It consists of 1 meter long straight wire. It is made up of manganese or Constantine. It is made out of manganese or made out of this material, the material of the wire. This is 1 meter wire. This wire connected here is 1 meter. It is made out of manganese or Constantine. Why this wire, that is wire AC, is of uniform cross section? That means the resistance per unit length is always same. Resistance per unit length is always constant. Two ends, this is a wire of 1 meter. AB is equal to AC is equal to 1 meter, that is 100 centimeter. This is connected to L shape copper strip. Why we are using copper strip? Because copper strip will have negligible resistance. That is, resistance at this point is equal to resistance at this point irrespective of this metal. That is why we use copper strips. Two ends of the wire, these two ends, this end and this end, is connected to a L-shaped thick copper strips A and C. Between the copper strips, between these copper strips, this is a copper strip, one more copper strip is placed with a gap. This is left gap, this is right gap. So that this also copper strip, this also copper strip, L shape, and one more copper strip. It is not continuous. And a copper strip is kept here, so that there is a gap in between the copper strips. A resistance box is connected to this gap between A and D. This also we can call it as point D. This also point D, because the resistance is same here also because of copper wire. A resistance box. Why we are connecting a resistance box? Because the resistance box we can fix the value of resistance at our will. So whatever one, and here in between this gap, a unknown resistance is attached in the right gap. This is left gap, this is the right gap. And a source of EMF along with the key is connected between the wire A and C. From here it is connected. So a source of E is connected across AC, a movable jockey and a galvanometer. See, from this point of this strip, copper strip, it is continuous. It is not connected with this one. It is overflowing on this one. A movable jockey. This is movable jockey through a galvanometer is connected from this end to. It can slide on the wire AC. So a source of EMF is connected across AC, and a movable jockey and a galvanometer are connected between B and D. Now, this we can treat it as this portion. This portion can be treated as a resistor R, and from, see, this is point A to D. A to D resistance R is connected, this R, and D to C. D to C resistance, unknown resistance S is connected, and from D to B, this length So this is a resistor P is connected. Then again B to C, a resistor Q is connected, which forms, and between A and C, EMF source with a key is connected. It means this meter bridge is forming this meter bridge or slide wire bridge is forming a Wheatstone bridge. So we are going to measure the unknown resistance S. This is unknown resistance S by balancing the Wheatstone bridge. Now let us see the working of this meter bridge. See, as it is, we have told it is based on the Wheatstone bridge, and this meter bridge works on Wheatstone bridge. First, now we select a suitable resistance box. First, we select a suitable resistance box, and the jockey is moving. The jockey, which is connected from D to along with a galvanometer, is free to move in the wire AC. The length of the wire is equal to 1 meter, which is equal to 1100 centimeter. If PQ or resistance, this is see, when it is in balance condition, see, this is equal to a Wheatstone bridge. When this is under balance condition of the Wheatstone bridge, what we can say, P by Q, this is this resistance, P by Q is equal to R by S when it is in balanced condition. If P and Q are resistance of parts AB, P is the resistance of part AB and Q is the resistance of part BC. Then for balanced condition, P by Q is equal to R by S for balanced condition. So this we have to remember, balanced condition. So what is the total length of the wire? The total length of the wire AC is equal to 1 meter. That is why it is called meter bridge, which is equal to 100 centimeter. Length of wire AB. This length of wire AB is equal to L centimeter. And obviously the length of the wire BC is equal to, this is 100 centimeter minus L, 100 minus L. This will be 100 minus L, and this is L. This is very much understood. It means the resistor P is L and the resistor Q is 100 minus L. Since the wire is this wire A to C, which is attached, it is of uniform cross section. So R, the resistance R is equal to resistance of the wire. The R is equal to resistance per centimeter of wire. Per centimeter of wire. It means suppose we have L centimeter, A to B is equal to L centimeter. It means the resistance P, A to B is the resistance P is equal to L into the length into resistance per centimeter. This is the resistance. Therefore, P is equal to its length. A to B, P is equal to the resistance P is equal to between the length AB and into R. Same way Q. What is Q? Its length is equal to, if this is L, this is 100 and this will be 100 minus L. 100 minus L into R. This is the resistance of P, this is the resistance of Q, where R is the resistance per centimeter length of wire. What is per centimeter? Per centimeter means every centimeter, see, if you want to measure for 5 centimeter, it means the resistance for the length of 5 centimeter is equal to 5 into resistance per centimeter length of the wire. So resistance of wire, it means we can say the resistance of the wire is proportional. Is proportional to what? Resistance of the wire is proportional to the length of the wire. Resistance is proportional to a length of the wire. So P is equal to, what is P? P is equal to resistance, P is equal to resistance of, P is equal to resistance P is equal to L into R, and Q, the resistance is 100 minus L multiplied by R. Therefore, under balance condition, this is under balance condition P by Q. See, this length is P, this length is Q, this is R, this is S. So P by Q, what is P? P is equal to P by Q, R by S. That is under balance condition, R by S is equal to P. P is equal, what is the value of P? L into R, and Q is equal to 100 minus L into R. What we are interested to find out, we can cancel out this and this. So S is equal to R into, S is equal to R into 100 minus L divided by L. This is the value of unknown resistance. So 100 minus L divided by L into R. Knowing this value of this length, if you know this length, multiply by the resistance per centimeter, and this will give the value of this arm, and this will give Q. This will give 100 minus L into R is the resistance of this wire, of this entire wire, and this is the resistance box. This resistance we fix. A known value we are fixing, that's why it is a resistance box. In resistance box we can select any resistance, and this is unknown resistance. By using this Wheatstone bridge principle under balance condition, we can find out the value of unknown resistance by knowing the value of R and L. Let us understand in a simplified way. See, this circuit seems to be a bit complicated, though it is not complicated. Let us draw the simplified circuit. See this point A and D. See, now we write A. Between A and this point, this also D and this also D. A and D, we have connected a resistance box. It means of known value. Then this is A, point A. And again from here to D to C, we have connected one more resistance, that is unknown resistance S, that is point D, A and D, and this is the point C. And here we have connected, what we have connected? We have connected here. From A to C we have connected here battery of EMF, and throw a key A and C. So this portion is now between A and C. Between A and C we connect a wire of length. We connect wire of length, and throw a galvanometer. We connect a jockey J. What is under balance condition? This is point A to B. So this is point A, and this also point A, and this is point C. See, it is very simple. This resistance is represented here, this resistance is represented here, and this wire is represented here, and we are connected a battery here. And this is the key. When the key is switched on, when the key is on, the current will pass through this. Current will pass through this wire. The circuit will complete. And from D we have connected through a galvanometer. Through a jack. We have connected jockey through a galvanometer. In balance condition means the current will be flowing from here to here, because from here to here current will be flowing. We move this jack from across A to C. That is, we move from here to here, here to here, where we get null deflection, till we get null deflection in galvanometer, See, when null deflection in the galvanometer means what? It is in balanced condition. It means no deflection will be in the See, galvanometer is a device in which a small current is flowing. A small current is flowing the galvanometer, it will show deflection. It indicates the presence of current in the circuit. So when there is no deflection, it means there is no current from here to here. That is from here to here. This is point D and this is point B. This is a jockey J. So now A to D is forming as the resistance R, and A to C, D to C is unknown resistance S, as it is here written, and AB is equal to L, and this portion AB is equal to L, and this is total is 100 centimeters. If this is L, this will be 100 minus L. So when balance condition means we move the jockey along this wire and we stop at the point where there is no deflection in the galvanometer. It means where there is no deflection means the current should pass through from here also passing. It means there is no pass of current from here to here. That is called null deflection of the galvanometer. It means the Wheatstone bridge is balanced. Under this condition only we write, that is R by S is equal to L into R by S, L into R divided by 100 minus L into R, so that we find the unknown resistance. This has get the unknown resistance is equal to 100 minus L divided by L into R. We have to remember what is balance condition of this. This is equal to a Wheatstone bridge. We are balancing it. How we balance it? We move the jack and we move this jack on this wire AC, where we get zero deflection in the galvanometer. That point is called null deflection point. It means the bridge is said to be balanced at this condition. The bridge is balanced when there is no deflection in the galvanometer. It means no deflection in the galvanometer means this portion forms one arm of the Wheatstone bridge. This is another arm, this is another arm, this is another arm. Then under balance condition we apply this one and we find out S is equal to 100 minus L divided by L multiplied by R. See, R is a known value. Length, we can get the length. This is the length of this one, because AC is equal to L. And AB, what is AB? AB is equal to 100 centimeter. AB is equal to L and BC is equal to total length minus this length. So this is known as the balance condition. Simply, this is a very simplified circuit. Instead of drawing this one, we can draw this one. Take this represented by two resistors and this wire. This wire is represented here. The jack is from this point to here, this point to here, and the connection is connected between A and C. So with this we can realize very simple circuit. With this we will be able to solve lot of problem instead of this circuit.